So here we are for our acid-base titration for 163L. Here is my setup that I will be needing to do my titration in. I have my pH meter, which I have already gone ahead and calibrated. You can watch the video provided in order to learn how to calibrate the instrument yourself. I have my 50 milliliter burette here. I have already rinsed it and washed it, as you can see from the video prior. Now I will take my base sodium hydroxide and fill it. I have my funnel up top here. Now I need to go back through and make sure that there are no air bubbles in it, and also to top it off to our 0 mark. So I have my waste beaker here, which I use during my washes. I will go ahead and lower my solution down to the 0 milliliter mark. As you can see, I still have an air bubble caught in the tip, so I need to let solution flow in order to release all the air trapped inside. So now I no longer have any air remaining in my tip. Double checking my volume, I can see that I have gone too low on my sodium hydroxide. So I'll finish topping it back up and then readjusting it back to our 0 mark. And there we are. I now have my 50 ml burette filled with sodium hydroxide, and I have removed all the air from my system, so I can remove my waste beaker, and now I can attach my beaker that I will be using for the titration. Here is my probe that I will need in order to read the pH of the solution. So I need to lower this down into my beaker. Be very careful with the probe since its tip is made out of glass. You need to have it sitting above our stir bar that we have inside the beaker. As you can see, there is space between the tip of my pH probe and my stir bar. So now I can go ahead and take my unknown hydrochloric acid, and I can add 25 mils to my 250 ml beaker using my graduated pipette. Cap it with your thumb in order to control the rate at which you lose solution. And now I will first add 10 milliliters, and then I will need to add my second 10 milliliters. And remember, the tip is included in the total volume here, so we do not need to stop at the 1 milliliter mark. We can dispense the entire volume of our graduated pipette. And then lastly, we just need 5 milliliters. And now we have 25 milliliters of our unknown hydrochloric acid inside of our beaker. Now I will add several drops of my phenolphthalein indicator. Our phenolphthalein indicator in the presence of acid does not have any form of a color. However, in the presence of base, it will start to turn pink. I will mix it into my solution slightly. And now that everything is set up, I can start my titration. We have standardized sodium hydroxide in our burette, which means that we know exactly how many moles of sodium hydroxide we are going to be adding to our solution just by watching the volume. And then as we go, we will need to be taking pH measurements the entire time. So I'm going to get an initial pH measurement by sticking my probe down into my solution. As you can see, I have a pH of 1.42, so I will need to take and record my pH. So our initial pH at 0 milliliters added is 1.40. We can read that because our pH meter reads ready at 1.40. Now I will bring my pH probe back up away from my solution, check to see that it's not getting hit by my stir bar. It is, so I'm going to raise it a little more. And now I can begin titrating. Every 2 milliliters of sodium hydroxide that I add, I will want to check the pH again. So I will slowly open my stopcock, and I can add 2 milliliters. As you can see, there is no color change from our indicator, which shows that we are still acidic. So I will now dip my probe into my solution, and after 2 milliliters, my pH is 1.42. Now I will add another 2 milliliters. So at 4 milliliters, we have a pH of 1.48. I will add another 2 milliliters. You can see that there is a slight pink color where our sodium hydroxide is entering our solution. That is our indicator showing the color change. At 6 milliliters, we have a pH of 1.54. As you can see, we are slowly increasing in pH as we go. At 8 milliliters, we have a pH of 1.59. At 10 milliliters, we have a pH of 1.66. I'm slowing down the rate at which I add my solution in order to be sure that I don't over-titrate my solution. If I over-titrate, I will not have an accurate measurement at the end, so I'm taking my time, since we do not know how much sodium hydroxide we will need to use to titrate our hydrochloric acid. At 12 milliliters added, we have a pH of 1.74. At 14 milliliters, we have a pH of 1.83. As you can see, the pink color from our indicator is lasting longer in our solution, which means we are slowly approaching our endpoint. Once we start to see it linger for much longer is when we will slow down significantly and add drop-wise. At 16 milliliters of sodium hydroxide, our pH is 1.93. At 18 milliliters, we have a pH of 2.06. At 20 milliliters, our pH is at 2.25. Our pH is starting to increase significantly when we add our sodium hydroxide. This is another indicator that we are nearing our endpoint, since as we neutralize the acid with our base, we are starting to have a pH much closer to neutral. So at 22 milliliters, we have a pH of 2.61. So I'm going to be careful now in this next one to make sure that I don't overshoot the endpoint. As you see, our indicator is staying for much longer. At 24 milliliters, we are at a pH above 5, which means we are very close to our pH of 7, our neutral, which is our endpoint of the solution. We have a pH of 5.83 at 24 milliliters. So I'm now going to start adding dropwise. I'm going to record my pH about every 0.2 milliliters of sodium hydroxide I add. So at 24.2, I'm at a pH of probably 6.04. We will see what our meter says. Yep, 6.04. Now I will add another 0.2, and now we are at a pH of 6.26. If you recognize a pattern, we were taking pH measurements every 2 milliliters starting off, and we would have an increase of about 2 to 10 pH every 2 milliliters. Now we are down to adding 0.2, and we are getting about the same pattern. I will add several more drops. About 4 drops from our burette is our volume that we are going for. So we are at 6.4H for our pH. At 24.8, we have a pH of 6.70. We are very close to our endpoint, so I'm going to be very cautious now and watch my solution very carefully as I add my base. I only want to add 1 drop at a time, and now we are at 25 milliliters. Our pH is at 6.98, so we are very, very close to our endpoint according to our pH meter. So again, I'll be very cautious and add drop-wise my solution. And now looking at my solution, I can see that there is a slight pink in it still. However, it is now mixed and gone away. So that means I am very close to my endpoint, since it is taking several seconds for the pink color to fade. So in order to help visualize this, I'm going to place a white sheet of paper underneath my beaker. This will help me see the pink solution, since there is more of a contrast. And as I look, my solution is a very light pink. It may be a little hard to see, but this is our endpoint. We do not want to go beyond this, since it will turn very dark pink and show that we have gone too far past. As you can see, our pH meter is reading a pH of 8.11 with a final volume of 25.2 milliliters. We will wait 20 seconds to see if our pink indicator goes away. If it does, that means we are not at our endpoint. If 20 seconds passes and we still have pink, that means we are at our endpoint. Based on the pH meter, this would make me feel that we are at the endpoint, since our indicator turns pink in the presence of base, not necessarily at a pH of 7, which would be the neutralized point of our solution. 20 seconds have passed and our pink indicator is still there. This means that we are done with this titration, and we have used 25.2 milliliters of our 0.1064 molar sodium hydroxide. we can now go and calculate exactly the molarity of our unknown hydrochloric acid and figure out what its molarity is. To be sure about this, I will repeat and do one more titration, and that will allow us to have 2 data points to know exactly what our molarity of our hydrochloric acid is. So now that we have hit our endpoint, we're actually going to continue adding sodium hydroxide until we have added 50 milliliters of sodium hydroxide to our solution. We will be measuring pH every 2 milliliters now. We have recorded our 25.2 milliliters as our endpoint. So now we will see what happens when you over titrate the solution. So now I have added another 2 milliliters. As you can see, my indicator is a very deep pink. This shows that we have over titrated the solution. You can see that our pH now is reading at above 10, so we are now very basic. Now at 29 milliliters of sodium hydroxide added, we are at a pH of 11.23. We will see if that is our final pH, 11.24. Now at 31, we have a pH of 11.57. As you can see, we are slowing down in our increase in pH as we are becoming more basic. We are now past our neutral zone, and we are now making just a basic solution. At 33 mils, we have a pH of 11.74. At 35, we are at 11.86. At 37, we are at 11.95. At 39, we are at 12.01. At 41, we are at 12.06. At 43, we are at 12.11. At 45, we're at 12.15. At 47, we are at 12.19. And our final measurement will be at 50 mils added. We are at 12.23. So this shows as we go and add more base to the solution past the endpoint, once we start to reach the higher basicity of the solution, we no longer have a large increase in pH. It starts to slow down, which is a pattern we saw initially when we were adding base to our acid. We were increasing by small increments initially, then larger and larger as we became neutral. Now once we passed our neutral point between 7 and 8, we started to increase in basicity very rapidly in large jumps until we started to get to about 40 mils of added sodium hydroxide, where we started to slow back down into a very slow climb in our basic pH. In this next part, we are investigating the acid content of consumer products. To start, we are going to be using vinegar or acetic acid. We have a solution of 5% vinegar right here. This is the approximate concentration. We do not know for sure, which is why we are going to be titrating it with our now standardized 0.1 molar sodium hydroxide. We want to use about 40 milliliters of our sodium hydroxide. So through our calculations, we have decided that we need to use about 5 milliliters of our vinegar in order to use about 40 milliliters of our sodium hydroxide. Now that I have added my 5 mils of vinegar, I can add 10 drops of Thymol Blue Indicator and swirl. We are getting a pinkish color, but again, that is fine for Thymol Blue because that is just what it indicates at if it is at a significantly low pH. So I can start my titration. As you see, we've already turned back to the yellow color that we expect. I have quite a buildup of air bubbles in my solution, so I just want to kind of swirl and let them settle before I continue. And there we go. Now that I've eliminated most of those, I can go back to titrating. I'm starting to have my blue color of indicator last in my solution, so I've slowed down to dropwise addition. My blue indicator is now lasting quite a bit longer in solution, so I'm very carefully adding 1 drop at a time. And there we go. I have now reached my endpoint. I'm at my light green indicator color, so I can stop and record the amount of sodium hydroxide I used for titration. So I checked and I used 42.9 milliliters of sodium hydroxide, and upon double checking, I've confirmed I've used 42.9 milliliters of my standardized sodium hydroxide solution in order to titrate my roughly 5% vinegar solution. We now have everything that we need in order to calculate the true concentration of the acetic acid in our vinegar. Next, we are going to be titrating aspirin to check its acid content. This bottle says that it has 325 milligrams of aspirin per tablet. So I'm going to now take 1 tablet from the bottle and add it directly to my flask. I'm going to take 25 milliliters of DI water and add to my flask. And I want to swirl this until my aspirin tablet begins to crumble and dissolve. This can take some time. If you want, you can crush the tablet prior to adding it to your flask in a weigh boat. However, you want to make sure that you have pre-massed that weigh boat on a scale. That way you can see how much aspirin you have possibly lost as you crushed the tablet. But as you can see, it did not take too long for us to have our tablet dissolve and crumble into the water. Now that it has separated, I'm going to be adding 25 milliliters of 95% ethanol. We are adding ethanol in order to fully dissolve our tablet. The majority of our tablet has dissolved into our solution. Starch is used as a binder in these aspirin tablets, which the starch may or may not dissolve into our solution. So I'm going to take it as it is and add my thymol blue indicator. As I continue swirling during the titration process, if there is any slight bit of aspirin left over, it should dissolve into solution during the titration. I've added my 10 drops of thymol blue. We are getting our yellow color into our solution. Now I can take and begin titrating. According to my calculations, I estimate that I should need about 18 milliliters of sodium hydroxide here to titrate my aspirin tablet, if the label is correct. I'm starting to see some flashes of blue in my solution, so I'm going to begin slowly adding drop-wise. Thymol blue is yellow in the presence of acid and blue in the presence of base. Since we are trying to titrate to our neutral pH, we expect actually a greenish color to be our endpoint, since this is the transition color between yellow and blue. I'm very near to my endpoint now, since the flashes are taking much longer in order to dissipate. And there we go with that final drop. I have gotten my light green color in solution, so I can stop and record the volume of sodium hydroxide I used, which is 17.7 mils of sodium hydroxide. And now we can go ahead and calculate the true amount of aspirin that we have and see if our label was correct. Now that we are at the end of the lab, I need to take care of the sodium hydroxide still within my burette. So I have my rinse beaker here. I'm just going to empty the remainder of my sodium hydroxide into my beaker, and this will be disposed of in the acid-base waste in lab. And then once I am done, I will take the emptied burette, flip it upside down and clamp it to my double burette clamp. That way it is ready for use for the next lab. If you are the final lab at the end of the week, you will take and actually rinse the burette with water and then fill it and cap it so that it can be put away into storage just like you found it when you got it out originally. So now that my burette is empty, I will take, invert, and reclamp, and now I can leave the burette like this for the next lab. Now I will go and dispose of my sodium hydroxide.